Each week there will be 2 quizzes. A quiz at the beginning of the week and a quiz at the end. The quiz at the end will cover the material that we've learnt during that week and will be more detailed. The quiz at the beginning is there to prompt you to read the book and understand the definitions of the words that are in this chapter before you progress. Typically, we're going to take the material on this first quiz of the week from the end of chapter summary. So the bare minimum that you could do is just read the end of chapter summary. And here is an end of chapter summary for chapter 1. It's on page 30 of the textbook, which is also tagged at the bottom of the Blackboard page for chapter 1. And what I'll do right now is run through some definitions and do a tiny little bit of algebra, and that should be enough to get through the first quiz. First quizzes of the week close on Mondays, but because this is our first one of the term, this week's quiz will close on Wednesday. But get into the habit of getting this work done by a Monday. So, chemistry is a scientific study of matter. Matter is anything that occupies space. So it has mass, it occupies space, it means it can be measured. Matter is composed of atoms, and an atom is defined as the smallest indivisible particle. That's no longer true. We'll talk about that later. An element contains only one kind of atom. And then we have these 2 words, molecule and compound, and we're not quite ready yet to split what they mean because we haven't learned enough to differentiate when to say one or the other. But molecules and compounds are combinations of atoms stuck together. A mixture is 2 or more compounds occupying the same space. And there's several different types of mixture. Mixtures can be heterogeneous, meaning that they come from different phases or different states of matters, like mud is sand and water. Mud is a mixture. The big thing with mixtures is they are occupying the same space, but they are not interacting chemically, which means that all mixtures can be separated back into their components at the end. A physical change is when the material that you are looking at changes its physical state, its state of matter, from a solid to a liquid to a gas. And this little symbol right here is a reversible arrow, which means that ice can be converted into water, water can be converted into steam, steam can be condensed back into liquid water, and that liquid water can be frozen. And at no point does the identity of the chemical change. This is a physical change. The chemical stays the same. It's just its physical state of matter changes. Now, in a chemical change, something happens that moves the atoms around inside the compound or inside the molecule, and we have a new connectivity between the atoms. An intensive property is something that doesn't depend on amount. Boiling point is a number that's an intensive property. If I have a small pan of water and a big pan of water, and I put them both on the stove, they both boil at the same temperature. So the boiling point of a pure liquid is an intensive property. It doesn't matter how much of the liquid you have, it boils at that particular number. Fundamental units. Units are fundamental if you cannot divide them into something smaller. And fundamental units for us in science are going to be mass, the kilogram, distance, the meter, time is in seconds, energy is joules, and temperature is Kelvin. We only use the Kelvin scale. Celsius is useful. We don't use that other temperature scale. Kelvin never goes below 0. So there are no negative numbers on the Kelvin scale. 0 degrees Celsius, where ice freezes, is 273 on the Kelvin scale. And because the Kelvin scale never goes negative, we can use it reliably in calculations, and our numbers will not just arbitrarily go crazy because, well, your temperature, which is a made-up number almost in itself, became negative. Derived units are combinations of other units. So if you've watched the other video, you'll see miles per hour, meters per second, mass per volume. These are all derived units because they're combinations of other units. Accuracy is how close your answer is to the actual value. Precision is different from accuracy. What precision is, it's the amount of detail that's in your answer. And we measure detail, because these are measurements, numbers, with significant figures. So the difference between precision and accuracy could be if I asked you what time it is and you said it's 10:15. It's kind of a vague number. And I asked somebody else and I said, what time it is it? And they said it is 10:14 and 36 seconds. That second answer has more precision in it. Now, if I asked a third person and they said it is 2:32 and 21 seconds in the AM, their answer also has lots of precision in it. But if it really is 10:15, then their answer has lots of precision, but no accuracy at all. So precision and accuracy are not linked together in any way at all. They are allowed to float completely free of one another. Contrary to what most people think, science is not a topic. People seem to think that science is a subject that you go away and study. No. Science is a method of observation. Science is a method. And what that method revolves around is unbiased observation. So we're not allowed to have a goal ahead of time and then go and cherry pick observations to make the world match what it is that we think we want to tell the world is going on. That's not the way it works. So we're going to take observations. The more observations you have should statistically lead to a better picture of what the reality is. There is a fabulous word in science that currently is not up on the board. It's called falsifiability, and it means you can never actually prove anything correct with more additional data that confirms your opinion. You, however, can prove something wrong with just the one piece of data. So we're going to take observations. More is usually good, but it's easier to disprove something than it is to prove something. And we're going to take that observation and try and spot some trends, try and build some rules out of those observations. And then the really important part is that we have to test that our observations fit that pattern, they fit that rule. And if you can test your observations to fit the rule and it works, then you've got yourself a theory. Theories typically live right here in something called the paradigm. And the paradigm is not the truth, it is the best available answer. So scientists don't get upset when you prove them wrong, because we understand that you cannot prove something to be correct unless you're in math. There are math proofs, but in the other sciences, no. It's easy to prove something wrong, and then we adjust our worldview, our paradigm, We fit the new pieces of information into that, and then we move along. Okay, we're almost to the point where we're going to start using numbers, and that means we need to make sure that people understand just the tiniest amount of algebra. If in this little symbolic equation, A represents a number that is equal to B times C, so A equals B times C, there will be times when we want to find out what the value of B is. So we isolate B on its own and move C away from it. We have to move the C across the equal sign. When you take any value and you move it across the equal sign, it changes from being a numerator on the top line to being a denominator on the bottom line. So A divided by C is equal to B. And of course, if we wanted to know what C is from A equals BC, then we would do the same thing by moving the B across the equal sign. Anytime you move a value across the equal sign, it goes from being a numerator to a denominator, or from being a denominator to being a numerator. So let's work through a problem. Gold has a density, remember density is characteristic for pure materials. Gold has a density of 19.3 grams per milliliter. What volume will 2.25 kilograms of gold occupy? Okay, so the question is giving us density. Density is a derived unit that is made up of mass and volume. And it also gives us a mass. It's asking us to find the missing value, and the missing value here is volume. We know that density is mass divided by volume. So we're going to do our little reshuffle to get volume to be on its own. To isolate for volume, volume has to go across the equal sign to change from being a denominator to being a numerator. And then I'm going to take the density that's here and move that across the equal sign. And we're going to find out that volume is mass divided by density. So now I know what framework to put my numbers in. I'm going to put the numbers in. And one thing that's really, really important is to put the units in the calculation while you're doing it. And I know this is going to feel like extra work and it's going to look distracting, but it is to your benefit. I didn't want to do it when I was a student, and I was wrong. I do it now, and math makes a lot more sense to me now than when I was a student. Because when we put our numbers from the question into our formula, we see that the mass goes on the top, 2.25 kilograms, and our density goes on the bottom, 19.3 grams per milliliter. Now my goal is to find a volume. Volume can be expressed in liters or in milliliters. There's my volume right there, milliliters. And to get my milliliter out of this question, my masses have to cancel. And they're not going to cancel while they're in different variations of the unit, because that number's in kilograms and that number's in grams. So I'm going to have to change the kilograms into grams before my number will make sense, which is why we do things slightly longer. The slightly longer way makes more sense. So I'm going to take my mass, 2.25 kilograms, and then I'm going to put into my calculation a unit conversion. My unit conversion says that 1 kilogram is equal to 1,000 grams. And the reason that I've done it this way, with the kilograms on the bottom here and the kilograms on the top right there, Those kilograms now cancel each other out, and I have converted my mass into grams. And then I take what it says in the value of density. Gold has a characteristic density that is 19.3 grams per milliliter. That tells me that there's another conversion factor here, that 1 milliliter of liquid is equal to 19.3 grams. So my next conversion factor puts a milliliter on the top and 19.3 grams here at the bottom. And those grams cancel, and those grams cancel. And now when all of these numbers work their way out, the only thing that I'm left with at the end is milliliters. This approach to breaking a calculation up into a series of conversion factors is called dimensional analysis. The slightly more old-fashioned way of doing things is to just do a separate little calculation that says, hold on a minute, 2.25 kilograms is 2,500 grams, and now grams divided by grams cancels, and something divided by something divided by milliliters flips that milliliters all the way into the top. And so my answer is going to pop out here. And if you do that calculation, you come up with an answer that says 116.58031. Because my calculator doesn't understand the concept of significant figures. The mass has 3 significant figures. The density has 3 significant figures. Because this is a division, my answer is allowed to have 3 significant figures in it, which means I only get to use this part of my answer. And because 116.58 is actually closer to 117 milliliters than it is to 116 milliliters, the best answer in this case comes out to be 117 milliliters.